Good morning, everyone. I'm Dr. Anjan Das from Department of Chemistry, SRM Institute of Science and Technology, Kattankudu, Chennai. So today I am going to discuss about the pharmaceutical aids. So first, let us know what is the pharmaceutical aids. What is the definition? So substances which are little or no therapeutic value but are necessary in manufacture, compounding, storage, etc. Pharmaceutical preparation of drug or doses from. So these are pharmaceutical aids like some binding agent and all these things. So they include solvents, diluting agents, and suspending agents, and emulsifying agent, antioxidant, preservatives, pharmaceuticals, coloring agent, and flavoring agents. So substances added to the pharmaceutical preparation to protect them from the chemical changes or microbiological action. They include antibacterial agent and oxidant. So, pharmaceutical aids are the drugs or substances which have no or little pharmaceutical effect, as I told, but they are very essentially used in the preparation of pharmaceutical drug form, like tablet, injection, emulsions, and ointments. So, substances added to pharmaceutical preparation to protect them from chemical changes or microbial actions. They may be plant, animal, mineral, or synthetic origin. So there are different kind of pharmaceutical aids available from the nature, and pharmaceutical aids of natural origin. I made a table. You can see it. So we can make classes and what are the examples like coloring agent. We can select turmeric, chlorophyll, caramel. Okay, all these things, and then flavoring agent like cardamom, cinnamon oil, rose, orange peel, nutmeg. Sweetening agent like honey, sucrose, lactose, and licorice. Okay. And then binding agent like mucilase of acacia, and then mucilase of tagacanth 2, and then percentage starch solution, certain percentage, and then dilutant like lactose, starch, okay, all these things, and cinnamon water, and then disintegrating agent like isopol methyl cellulose, okay, a carboxymethyl cellulose. These are some examples. And lubricant like talc, cocoa butter, and magnesium trisilicate. Emulsifying agent like gum tragacanth agar and gum acacia, and then suspending agent like bentonite, gelatin. Okay, so these are the examples suspending agent. And then ointment bases like bee wax, supermatis, and then lanolin, all these things. And then thickening agent like methyl cellulose, pectin. Okay, and then filtering agent like kaolin. So let us discuss about the bentonite. So bentonite are absorbent in bentonite absorbent aluminum phyllosilicate clay, consisting mostly the monomallein nitrate, and it has the incredible ability to increase as much as 14 times of its original volume. So they mainly exist in cationic form of organic compounds such as aromatic or aliphatic hydrocarbon, and are employed to modify high cation exchange capacity. So bentonite is a layer of natural silicate clay mineral having numerous properties such as a large specific surface area, great absorption, and interlayer exchangeable cation. Formation of bentonite. So bentonite is a material derived from alternation over geological time periods for glassy material emitted from volcanoes like tuff or ash, or from the alternation of silica bearing rocks such as granite and basalt. Okay, so bentonite only forms in the presence of water. So there are different types of bentonite. So two types majorly. So two types of bentonite are recognized, and uses of each depends on specific physical properties. So type one is sodium bentonite. So sodium bentonite is the type of soiling clay. It has a single water layer particle which contains sodium plus as the exchangeable ion. And then type 2 is calcium bentonite. Calcium bentonite is the non-soiling clay. It has a double water layer with calcium 2 plus as the exchangeable ion. So distribution, it is generally found in Rajasthan, Karnataka, Kerala, Gujarat, etc. So what is the chemical constituent of bentonite? So aluminum oxide, and then iron oxide, magnesium oxide, calcium oxide, titanium dioxide, potassium oxide, and sodium oxide. So what is the preparation process? So bentonite deposits are normally exploited by quarrying, like deep hole. Extracted bentonite is extremely solid, even with a moisture content of approximately 30%. The material is initially crushed and, if necessary, activated with addition of soda ash. Bentonite is subsequently dried, air and or frost drying to reach a moisture content of approximately 15%. So according to final application, bentonite is either sieved like a granular form or milled into powder and superfine powder form. For special application, bentonite is purified by removing the associated gangu minerals or treated with acid to produce acid activated bentonite. So what are the physical properties? So specific gravity is like 2.49 to 2.72. Specific surface area is like 370 to 487, and oil absorption like 73 to 87, and water absorption is 1.115 to 207 percentage by weight. Adsorption resistance is 80 to 90, and absorption of water vapor by percentage 11 to 17%. Now let us know what are the uses of this bentonite. So based on the physical and chemical properties, the bentonite can be used in the following industries like bleaching of edible oil, oil absorption, odor and liquid absorption, absorbent, wastewater treatment, cast iron industry, okay, pelletizing like molding of materials into shape of pellets, filtering and clarification. So now let us talk about the kaolin. So what is the general name or synonym like bolas alba, china clay, porcelain clay, white bowl, argilla. So this kind of thing known as kaolin. So kaolin is a chemical composition is hydrous aluminum silicate. Okay, and then percentage of alumina is 39.3 percentage. Silica is 46.8 percent, and the water content is 13.9%. So, what is the physical characteristic of this kaolin? So, it is a soft clay material. A particle size of a heavy kaolin is 20 micrometer in diameter, and fine particle 2 micrometer. Slightly plastic, normally white in color, and unqueous and soapy in to touch, and then fusion point is 700 to 800 degree centigrade. How we can make the kaolin? So kaolin are derived from pignamides or from hydrothermal alternation. They may also occur as a blanket deposit in extensive area of igneous metamorphic rocks. So distribution, so Garo Hill of Assam, Bihar, Maharashtra, Madhya Pradesh, Delhi, Kerala. Okay. And chemical constituent kaolin group contain calamite, nacorite, dickite, anacite, and halocites, all aluminum and silica with traces of magnesium, calcium, and iron. Preparation. So preparation, kaolin is prepared when the rock is mined, excavated, and impurities are washed with water and then powdered. The rock is elutriated with water and large size particles are separated. On allowing the turbid to settle, heavy kaolin containing particle of large size and kaolin containing particle of small size are separated and then dried for the use. So, what are the use of this kaolin material? So, dusting powder, okay, poultice, carrier of heat, filtering agent, cleaning agent. Fine kaolin is used internally as an absorbent and to coat irritated intestine mucosa in case of diarrhea, dysentery, and intestinal fermentations. They are also used to manufacture porcelain, pottery, bricks, Portland cement, plaster mineral, electric and heat insulators, clarifying liquids, drying, and emollients agent. So now let us talk about talc, the softest material. Okay. So synonym is talcum powder or bath powder. So talc is a hydrous magnesium silicate mineral with a chemical composition of magnesium 3, silicon 4, oxygen 10, and OH whole 2. So when a large amount of iron substitute for magnesium and then mineral is known as minnesotite. When large amount of aluminum substitute for magnesium, the mineral is known as pyrophilite. So what is the definition of talc or how it gets? So talc is a pyrosilicate mineral that clips into thin sheets. These sheets are held together only by van der Waal bond, which allows them to easily slip past on another. This characteristic is responsible for talc extreme softness, its greasy to soapy feel, and its value as a high temperature lubricant. So how does talc form? So talc is a mineral that is most often found in the metaphosphoric rocks of convergent plate boundaries between an ocean and continental plate. It forms from these two processes. First process, most large talc is formed when heated waters carrying dissolved magnesium and silica reacted with dolomitic marbles. Okay, second process of talc formation occurred when heat and chemically active fluids altered rock such as dunite and supernatite into talc. Let us now know about the physical properties of this talc. Okay, so first let us check chemical classification like it is we all know silicate only, and then a crystal system. So this could be monoclinic or triclinic, and then color, it could be green, white, gray, brown, or it could be colorless also. And rock type, it's metaphoric. Optical properties, biaxial with negative optical rotation. Cleavage is perfect. So Mohs hardness is 1, specific gravity is 2.7 to 2.8. Chemical composition is magnesium 3, silicon 4, O 10, OH whole 2. So transparency, transparent to opaque, refractive index. These are the value in alpha, and beta, and gamma. Luster, it's purely. Now to see what are the varieties available of talc. So the beconite, a fibrous variety of talc resembling asbestos, okay, resembling all asbestos. Then chromium talc, a chromium variety of talc. Okay, polyphant stone, a grease green postone flag with white and brown, used since Norman times as the ornamental stone in churches. Then pseudolite, octaedral tax pseudopods, that is spinel, and then steatite, okay, a massive variety of talc with a greasy filling, often used for ornamental carvings, and then zinc tack, zinc bearing variety from the mixed space series formations. Distribution, where this kind of things found like Rajasthan, Maharashtra, Kerala, Gujarat, and Madhya Pradesh. And chemical composition, as I told, talc is the hydrous magnesium silicate mineral with chemical composition Mg3Si4O10 OH whole 2. Although the composition of talc usually stays close to the generalized formula, some substitution occurs. Preparation. Talc is a metaphoric mineral that results from the metamorphism of magnesium minerals such as serpentine, okay, pyroxene, amphibole, or olivine in the presence of carbon dioxide and water. This is known as talc carbonation or sterilization and produces a suite of rocks known as talc carbonates. Talc is primarily formed by hydration and carbonation by this reaction. So this is the general reaction. We can see supertine reacting with the three molecule of carbon dioxide and giving the talc, and then byproduct is magnesium carbonate and water. So talc can be also formed via the reaction between dolomite and silica, which is typically scarification of dolomites. And so these are the some reactions. Also, it can form from bullshit and different form of talc come from different rocks. Uses. So talc in ceramics, we can use talc in paint, a lubricant, and as a filler in paper manufacture. Talc is cosmetics, talcum powder, and anti perspirant. Talc is talc in roofing material, coating in pharmaceutical product as glidant. Okay. Steric talc powder in medicine. Talc is used as a fluororeduces agent to prevent recurrent. Okay, electric cable, okay, electrical switchboard because of its resistance to heat and